This lesson we're going to simplify nth roots with variables involved. This is just going to be an introduction. We're going to look at simpler problems just to get the steps down, and then later we'll look at more complicated problems that might even involve absolute value. So let's start with our steps. Our first step is to separate. Now what that means is, because we're dealing with roots, there are going to be two primary rules that you'll use. For instance, if you have the nth root of a times b, you're going to use the fact that you can separate those into two separate roots. And so when we do these problems, you're going to be able to then work on simplifying them individually. So I'm going to put a box around this because this is an important rule then to use. And then the second rule we're going to use involves when you have a fraction. So if you've got the nth root of a over b, you can separate that into the nth root of a over the nth root of b. So it's the second one that we're going to use, multiplication and then division in separating them. Now, the second step we're going to use is we're going to simplify using fractional exponents. So you're going to convert into the fractional exponents, and then we'll be able to use some of what we know about fractions to be able to reduce and simplify. So simplify using fractional exponents. And then this next step is we're going to use later. It won't come up in any of the problems we're going to do today. So that's why it says later here, being a later lesson. But for this introduction, we won't use this. We're going to use absolute value when our index is even when necessary. It's not going to happen all the time, so our examples today won't include this step, but there will be times where you'll need to put an absolute value onto your result. Okay, let's use these steps to do a few examples. Now the first example I want to do is I want to just do a square root. So remember, when there's no index, it's implied to be a 2. So square root of 64, x to the 12th, y to the 20th. Now what I'm going to do is separate this using that rule. I'm going to make this into the square root of 64 times the square root of x to the 12th times the square root of y to the 20th. Now for this one, notice we know the square root of 64. So if it's not an exact number, we could go ahead and simplify using finding a perfect square. But this one is just 8. It's the principal root. Now this one I'm going to make into an exponent. I'm going to make it 12 over 2 because the exponent is 12, the index is 2, so you can make it into a fractional exponent. And for this one, it's going to be y to the 20 over 2. Notice 20 is the exponent, 2 is the index. When you make it into a fractional exponent, the index becomes the denominator. Now I can simplify those. I get 8x to the 6th power and y to the 10th. So notice I've taken this, this radical and I've simplified it using fractional exponents to reduce them down in order to get my final answer. Okay, let's do another example. This one, again, will still have an even index. I'm going to make it an index of 4. So the 4th root of 625 x to the 48th power and y to the 16th power. So the first step is we're going to separate it into different parts. So I'm going to do the 4th root of 625 times the 4th root of x to the 48th times the 4th root of y to the 16th. Now the 4th root of 625 you may or may not know. It might be something that you've done enough of these roots that you're aware of what the 4th root of 625 is. I'm going to just put it as a fractional exponent and do it on my calculator here in a second. Let's write each of these out though. This will be 48 as an exponent over the index, which is a 4. And then this one, my exponent is 16, it's the numerator. My index is 4, so I make it over 4. Now, I'm gonna go to my calculator and see, is there a 4th root of 625? And so if I put that in my calculator, I'm gonna take 625 and raise it to, I'm gonna put it in parentheses, though in this case, since it's raised up, I don't need it, but 1 divided by 4 is the 4th root. Is there a 4th root? Yeah, it turns out to be 5. So that's kind of convenient that it turns out nice and neat. So this is 5x to the 48 divided by 4 is equal to 12. And then 16 divided by 4 is equal to 4. So this is my final answer for simplifying this after separating it and then using my fractional exponents. The last one I want to do here, we'll have an odd index. I'll do the 7th root of 128, and this will be a to the 14th, and then b to the 35th. I'll use different variables here. You don't have to always have x's and y's. And so for this one, I'm going to separate it out. So 7th root of, let's make that a little clearer here. So 7th root of 128. When you write this, make sure you maybe even put the little shelf there so you know that's a 7th root rather than 7 times the square root of 128. This is wrong. This would be right, so make sure you write it correctly by keeping it up, raised up as a superscript. Maybe putting that little shelf there might help you recognize that. So this is not what we want. And then we're going to have the 7th root of a to the 14th, and then 7th root of b to the 35th. Let's go ahead and use our fractional exponents. 128 to the 1/7 power, a to the 14 over 7 power because of the index being the denominator, times b to the 35 over 7 power. Now this one we can do on our, try it on our calculator, see if it works. In this case it will. So let's do 128 raised up to the 1/7 power, and that gives me a 2. So this becomes 2a to the 2nd power, and then b, 35 over 7 is the 5th power, reduces down to that. So remember, the first step is to separate each of the pieces out when it's multiplied or divided. If you have a fraction, which we didn't do any examples here, but you can put the root of the numerator over the root of the denominator, and then use your fractional exponents to go ahead and simplify so that you get your result with the numbers and also the variables involved down to simplest form.